All right. For everyone who is joining us on Facebook or just filtering in, we have about 3 minutes here before we get started. Welcome. So what's the weather like in Corvallis today?
I was saying earlier, it's sort of been just a little bit of everything from minute to minute. We have blue sky for a bit, and it gets a little warmer, and then we get like totally dark gray sky raining, and it's spring in Oregon. So
Yeah, Pacific Northwest spring for
yeah,
sure.
I heard that you guys had snow the other day, not so long ago.
Yes, Southwest Colorado Springs. I'll say maybe because I do know from experience, I think it's slightly harsher than Pacific Northwest spring, just in the
Mm.
sense that it can be, wait 5 minutes and the weather will change. But
Mm.
these crazy spring blasts of snow are needed for sure. We didn't get enough snowpack this year, but they can
Oh
be a little
wow,
unnerving.
that's so strange because the Cascade Range has like record snow this year, so it's just weird how that doesn't distribute equally across the region.
No, it definitely doesn't. Yeah, we need all the water we can get, but after a while we get a little weary of the spring snowstorms
Mm,
and the mud that immediately follows. So
right, right.
we're kind of out where there's a lot of dirt roads. So.
Yeah, really, mud roads.
All right. Well, we just turned to 4 o'clock Mountain Time, so let's go ahead and get started. Thank you, everyone, for joining us for our webinar today. And before I introduce our distinguished speaker, just a couple of our usual introductory slides. If you don't know Crow Canyon, we are a nonprofit research and education center here near Mesa Verde on the Colorado Plateau. Um, During our presentation today, we are on Zoom, obviously, with many of you. We're also live streaming on Facebook if you feel the need to switch over. I know we have a lot of folks joining us today, so if you have questions at any point during the presentation, go ahead and put them in the Q&A section instead of in the chat in case people get to chatting. I will keep an eye on both, but it is easier for us to organize questions in the Q&A. And this will be on our YouTube channel after the fact with all of our past webinars. So if you are not already a subscriber to our YouTube channel, please check us out. I'd like to begin with an acknowledgement. Crow Canyon acknowledges the Pueblo, Ute, Paiute, Diné, and Jicarilla Apache people on whose traditional homelands our campus sits. With the work that we're doing here at Crow Canyon, we seek to bring light into the darkness of memory that these lands, waters, wildlife, and her descendants hold because of policies of removal, genocide, and displacement. We seek paths that support and align with Indigenous people and communities, and with gratitude, we honor the contributions of present-day Indigenous communities, descendants, and the colleagues with whom we partner and who help guide our work and our mission every day here. So thank you. Just a little update announcement. If you're not on our campus, you wouldn't know this, but we have our spring school groups coming. So 4th grade through high school, we'll be having many, many kids on campus this spring. We actually love this time of year. So just an FYI, if you happen to be around us, we have a lot of students piling into campus just starting this week. Our upcoming webinars in the next couple of weeks. Next week, we have historical and modern challenges of Native American identity formation, tribal enrollment, and blood quantum laws. And the week after, we have powerful pigment, unearthing the enigmatic Fremont red on gray pottery. So we have some really fascinating talks coming up in addition to today. So please continue to join us. Just as always, a huge thank you all day long on Thursday and in the week prior. We get donations pouring in from all of you who support the webinar series and support Crow Canyon in general. We are almost entirely supported by philanthropy. Particularly now. So thank you to everyone. We literally could not do this work without you. So without further ado, I am so excited to introduce Dr. Loren Davis, who is a professor of anthropology at Oregon State University and the executive director of the Keystone Archaeological Research Fund. He received his PhD from the University of Alberta in 2001 and joined the faculty at Oregon State University in 2004. His research focuses on the late Pleistocene archaeology and geoarchaeology of Western North America and East Asia as related to the early peopling of the Americas. He directed archaeological research at the site that he'll be talking about today in Western Idaho in 1997 and from 2009 to 2018, which produced evidence of early human presence in North America beginning at least 16,000 years ago. Without further ado, because it is not me you want to hear from today, thank you so much, Dr. Davis, for joining us.
Thank you. Thank you very much. It's really a pleasure to be here, and I appreciate the invitation. And I'm happy to share some information today that I hope is educational and informative to everybody watching. So without much more ado, let's go ahead and get into it. I'm going to share my screen and okay. So what I want to talk about today, what I want to talk about today is the work that I have done in cooperation with Nez Perce Tribe and with the Bureau of Land Management at a site that's been known in the archaeological literature for a long time called Cooper's Ferry. And it's been known to the Nez Perce people for much, much longer than this. And it's referred to as a site of a village called Nipéhe. And I want to talk about it in terms of the old record that's present there. Now, this site has been occupied for a very long time, and there's other stories that we could tell from an archaeological perspective. But today we're just going to focus on the earlier perspectives that we can do here. And as I'm talking about this, be thinking about questions you have, and I'm happy to stick around and answer them toward the end. And as my title says, Cooper's Ferry, Nipéhe, a pre-Clovis site in North America. So what do we mean when we say pre-Clovis? Like, what does this mean? Now, for some of you, this isn't new information, but we'll go ahead and just take a minute to get our bearings here. And you probably have heard of the Clovis Paleo-Indian tradition or Clovis culture or Clovis people. And this comes from artifacts that were excavated at a site called Blackwater Draw in the 1930s and then thereafter near the town of Clovis, New Mexico. And this helped to initially establish this pattern that is now known as the Clovis archaeological pattern, Clovis Paleo-Indian tradition. And the artifacts that are associated with Clovis are very distinctive, and they can include large but also small bifacially flake pointed spear points with a distinctive flute at their base. And what this means is there's a large flake that's taken out, and this is essentially an accommodation space. It's like you're trying to make a negative space so it can be mounted onto a stick. Other people think it has other engineering properties, but it is very distinctive, this removal of a big flake from the bottom of flute. These are widely distributed in the United States, and as you go north and south of what's now the United States, you find fewer examples of this. Radiocarbon dating shows us from sites where these were found in buried contexts in association with datable material. Radiocarbon dating shows us that the Clovis pattern dates to about this time period, between roughly 13,050 to 12,750. Some people have other numbers they might prefer, but we probably, for the discussion we're going to do today, we can just think about it as a benchmark of about 13,000 years ago. Well, again, what is the big deal about pre-Clovis? What does it mean about this? Well, most of the 20th century, the idea was that Clovis people represented the earliest evidence of people in the Americas. And there are some people who still believe this perspective. But as the story goes, human groups expanded from Northeast Asia, what's now Eastern Russia, sometime before 13,000 years ago, and they were able to walk across an exposed land bridge that was present during lower sea level. Lower sea level was everywhere around the world during the last ice age, because to make ice the size of continental scale things like Greenland or Canada, you have to have the water come from somewhere, and it comes out of the oceans. And these people would have come into what's now Alaska and Yukon. And eventually, when ice was receding, there would have been a gap that they could have walked south from the interior of Alaska, Yukon, down south through the province of Alberta, exiting into Montana and the Dakotas and places like this. Once they were out of this ice-free corridor, as it's called, they could have spread everywhere and began to distribute Clovis artifacts lots of places. This is how the model goes. Well, regardless of whether oh, sorry, I should jump back. Other people say that, well, no, that isn't how it happened. People may have come along the coast. Some people have said they somehow came along ice margin and ice pack from Europe. We're not going to debate these kinds of ideas today. That's really not the point of it. To add on top of this, indigenous perspectives say, well, we didn't come from anywhere. We're actually from this place. So the Nez Perce have a creation story that places them in what's now the state of Idaho, during the time before memory. So again, the purpose of this is not to argue about one way or another, but I'm just trying to set the stage for what we mean by Clovis. And regardless of whether people came via some interior route or a coastal route or whatever, it is clear that people did not arrive at Blackwater Draw or other dated Clovis sites first. That's not possible because they're in the interior of North America. So there must be some kind of other early archaeological evidence that predates about 13,000 years ago. And that represents the time when people are first coming into the country to become the thing that we will call Clovis. So simply put, pre-Clovis has to exist one way or the other. Now, the distinction here is that some people think about the concept of pre-Clovis from a short time perspective or a long time perspective. So some people favor a short chronology where people are moving rapidly from Northeast Asia only a few hundreds of years before 13,000 years ago. And other people think that, no, it took a lot longer for people to make their way from Northeast Asia into the Americas, and they maybe took thousands of years before 13,000 years ago to get here. And again, indigenous perspectives are very different than scientific perspectives. They would say this is all wrong, that people have just simply been here forever. Well, how do we demonstrate the idea that there could be evidence of people at an archaeological site before the timing of Clovis? That is, how do we demonstrate pre-Clovis evidence at a site? Well, we have to follow rules. We have to all agree to follow certain kinds of rules, or else we would just be talking past each other all the time. And so these are some pretty common rules that we will follow when we try to put forward scientific perspectives on early archaeology. So one, we need to find objects of clear human origin. So we have to be able to answer the question, are there undeniable artifacts or traces of some other type of human presence at the site? Humans don't have a monopoly on breaking rocks. Nature breaks rocks too. There are now lots of natural processes that do this. Nature scratches things and carves things up sometimes that can maybe look like human traces. So we really have to be careful sometimes not to be fooled by things that could be caused by non-human origins. The next is we have to provide good chronometric age determination. And what we mean by chronometric is that you have to use a technique that establishes age on the basis of measured numerical time. So this is not the same as saying I'm holding an object in my hand. It's like, boy, that just feels old. Well, that's not a chronometric age determination. Something like radiocarbon dating is a way to go. There are other techniques in geology that we adopt in archaeology. So the question is, can you provide a good numerical age on some kind of samples from the site that are older than 13,000 years ago? Well, beyond just getting an age, we have to show that the thing that you're dating actually goes with the objects that you say are evidence of human presence. And so we have to show clear association between dated objects and human objects. So is there evidence of human presence? And is it well dated by your chronometric ages? Why I say this is, I go to a place and I stand on um, a deposit. Let's say it's an ash deposit that was from a volcano that was created, 100,000 years ago, and I leave a footprint in that. Well, that doesn't mean that I was there 100,000 years ago. So we have to be careful not to mix up our associations between timing and things. And then lastly, can we reveal consistent environmental context? That is, in the site itself we're investigating, is there evidence about the past environmental condition that we can look at and measure? And does it make sense for the timing of the evidence that we're looking at? And what I really sort of mean by this is, if we're going to be talking about something like very early archaeological evidence at a site like Cooper's Ferry in Nipéhe, we have to be able to say, yes, the geology actually looks like an environmental condition that was present in the Northwest at about 16,000 years ago. It should look like this image I'm showing you here. That is, we should have some kind of evidence that the sediments and soils that were present at the site are being formed under glacial environments. And we'll talk about the details of this, but this is essentially a map of what we think the Northwest may have looked like during the early time period that people were living at the site. So the dark blue areas are impounded glacial lakes and flood areas that were created by these mega flood lakes and flood events. We have huge ice sheets that were coming down from Canada into the Northwest. The ice growing on the continent actually lowered sea level. As you can see to the left-hand side of Oregon and Washington, we had a lot of extra coastline to the west. So it was a pretty different world during this time. Now, Cooper's Ferry site is higher in elevation than the mega flood pools, than the Missoula flood and the Bonneville flood. So we don't see any evidence in the vicinity of the site that suggests that we have some kind of effect from that. And that's important because other parts of the Northwest, especially areas where we see these dark blue polygons of lakes and floods, would have been dramatically affected during the very early time that people were at the site. So that could be a reason why we're not seeing a lot of widespread evidence of people 15, 16,000 years ago. It just could be that the evidence hasn't preserved well. So here's a shot looking at the Cooper's Ferry site from across the river. As you can see, it's a semi-arid place. We do have some trees, but in some parts of the canyon, it's sort of bring your own tree. It's a hot place in the summer for sure. It can get over 120 degrees out in the sun at the very, very hottest time. And as I mentioned, the Nez Perce people know this place in memory. It's named, and it is the location of an ancient village site. And I'm told that there are people in the tribe who actually trace their own ancestry back to this place, this village. So it lives on today. Archaeologists have just simply, done work to try to catch up to things the Nez Perce already know. So I first worked here in 1997, and I worked here because I had read about work that an archaeologist named B. Robert Butler had conducted at the site in the 1960s. Now, this site is managed by the Bureau of Land Management, and I should say that all the work that I have done and will do in the canyon that's on federal land managed by the BLM. We do this in close cooperation with the BLM. In fact, all the things I'm going to talk about could not have been done except through the wonderful, wonderful collaboration we have with archaeologists in the BLM. And in particular, I want to say thank you to David Sisson, who's the archaeologist at the Cottonwood field office, which is just up the canyon away from where we work. But this is a view of showing the first excavation unit that we created in 1997. It's a 2-meter by 2-meter pit, and you're looking at one of the walls. It's just about the size of an elevator shaft that goes down into the site. Now, the site itself is truncated, meaning in the 1930s, there was a road construction project that came in and chopped about roughly probably 60% or more of the site away due to construction work. And so when we excavate here, we begin at about almost 9,000 years ago. So a lot of that record has been removed. So the thing to remember here is that the record we're going to talk about, except for that road building, would have been tremendously deeply buried. So it'd be very difficult to actually work on. And that could be also why we haven't found a lot of examples like this. But as you can see here, it's what we call a stratified site. It has sort of a layer cake sequence. You can see some different colors going on here. And each of these different colors represents different events of natural process depositing sediments, laying down new dirt, burying old surfaces, and sort of capping and capturing archaeological materials that get left behind. In 1997, we excavated down to the very bottom of the archaeological deposits here, and those are a gravel deposit at the bottom. But this whole sequence of photos shows us in the left-hand side. We were excavating in the very bottom, and there was a deposit of a sort of a sandy silt. And this is, now we understand it, as a wind-blown glacial dust, or loess. And that's consistent with, this time period of when we have a lot of glaciers grinding up mountains in the upper part of the Salmon River Basin. And this loess would have been washed downstream by the river, probably ended up on the beaches as a sediment, and then get blown onto the flanks of the canyon through time. But as it was accumulating, it's extremely low energy. And so when we were excavating through this, you see, like in photograph A and B and C, we started to go into the loess, but we were finding rocks in this, and they were in sort of a concentrated area. And I thought, boy, that's really strange. That doesn't make sense. We don't really live on a planet where rocks like this fly through the air, and it doesn't look like water. So created this deposit. As we dug a little bit deeper, each of these photos shows it going down, down, down. We got to photograph D, and here we have a circle you can see in the sediments. So all of a sudden we knew that this was something unusual. It didn't match the rest of the sediment. And as we went deeper, the circle of different kinds of sediment extended into the more densely packed gravel. So in the end, what it is we found was this was the interior of a pit. There was a large pit, and this is a 1 meter by 1 meter square that you can see in D where the circle is. So it's about the size of a 55-gallon trash can, roughly, that someone dug into the ground. And they dug this void into the ground, and then they put the sediment back in, and they, in the process of doing that, also put these objects on the right-hand side. So here we have some 4 projectile points. In the top, in the middle, we have some blades and some other kinds of flake tools. In the bottom line, we have a hammerstone and some cores and a scraping tool. So essentially, someone put the contents of what kind of looks like a toolbox inside the ground, and then put sediment back in, and then capped it with a layer of gravel, made a mound of gravel at the top. So in 1997, we had found this in a 2 meter by 2 meter pit, and we were just amazed, because this had never really been seen before in the Northwest. We weren't really sure what it is exactly or how old it was. Well, later we got radiocarbon dates on some of the things inside. There was charcoal we found at the very bottom of the pit in association with these stemmed projectile points, as we call them, stemmed points. We also found charcoal from the surface where this gravel pile begins. So we could date, we thought, the creation of the pit this way. And these radiocarbon dates came back like this. And so as I show radiocarbon dates through here, I'm going to show them in radiocarbon years first, and then inside the parentheses, you'll see the calendar years ago. So you can think of this as calendar years ago. Like how many years ago? So essentially it said, if we look at this evidence, that someone dug a hole and then began to fill it back in, including objects, 2 objects, one dated to about 13,000 or so, and the other one dating perhaps a little bit earlier than that. Now, when you're looking at wood, because trees can live a long time, you can get sometimes differences of hundreds of years in the same tree, even. The radiocarbon date in the middle dates different than the outside. That might explain the difference. So I wrote a paper with my advisor from the University of Alberta, Charlie Schwager, and we put this out here, that there was evidence perhaps of people living at the site making these objects, these stemmed points, at about this time. So that doesn't match the Clovis idea of how the earliest archaeologists and archaeology in the Americas should look. So you can imagine it made some people very excited, in a positive and negative way sometimes. So at first, I got a lot of feedback, we'll call it, from this. And but it's such a small sample. I wasn't entirely sure really what to make of it. Working with David Sisson, and also David worked with the Nez Perce tribe to get an agreement in place where we could learn more about the site, because we thought, this is really interesting what we learned in 97. And it would be great to be able to do more work here and expand on this and get more details and more understanding. So I started to work at Oregon State University in 2004. And so I had a much more stable job to do the kind of work that we planned to do next. And that was from 2009 to 2018, we excavated at the site for 10 years in a row. And we opened up these two areas that we call Area A and Area B. And this is a Google Earth image. If you know where to look in the lower Salmon River Canyon, you can find this photograph. A little plane flew over and took a shot of us working here. But for today, we're going to talk about first Area A, then we're going to talk about Area B, the contents and the things that we learned. So here's a view of more expanded perspective on the stratigraphy in sight. And we give it these names. You can just think of this as layers. So layer 6, 5, 4, layer 3. We're mostly going to talk about layer 3. Layer 3 is where the earliest archaeological evidence exists in Area A. And it is noted by its windblown glacial dust that has a soil developed. It has, you see this sort of whitish material through here, and a more of a rubified, as we call it, sort of a pinkish, reddish, oxidized deposit. As we work at the site, the goal is not to just simply find objects. We get this a lot. People are like, why are you digging so slowly? Why are you digging so in such a tedious way? Why are you just scraping with small tools? Why don't you just bring a big piece of equipment in here and dig it up and find the objects? Well, that's because our questions are more complicated than just simply, did the ancestors of the Nez Perce make stone tools? That's really all we would be able to say in the end, because we'd find a lot of stone tools, we'd find a lot of pieces of bone of animals, but we already knew those things. We already knew that people hunted animals with stone tools. So what we want to do instead is work out a lot of the details about the timing of things and figure out what people were doing and also what the world was like as they were living here. So on the left-hand side, one of my students, Sarah Skinner, is excavating, finding a whole bunch of very small items in place. We call this in situ. You want to find them in the ground, exactly where they were left. We want to map them very carefully and put them in bags and record them. And this becomes the basis for reconstructing the presence of people here at the site through time. And on the right-hand side, you see we use hand tools. This is kind of a stereotypical thing you think about with archaeology, the scrapey approach of excavating this really big hole in the ground using very small tools. It just takes a very long time. But it's very careful in the process of doing that. We don't really miss anything because we also screen all this sediment through very fine screen. And anything we don't see by excavating by hand, we're going to find it in the screen. So we'll be able to put things back together as best we can. So here is an end product. So this is just a plan view looking down. Each of these squares is a meter, roughly a yard across. And in this, you see a bunch of symbols. And so the symbols just sort of correspond to different kinds of material. The black triangles, for example, are flakes from the production of stone tools. And you see a whole bunch of numbers with arrows, and don't get too worried about that. I'm going to explain the timing of things here next. But this is just one view. Look above and down. And you can see that we found other pits. So there are other pit features that have a whole bunch of items in them. This is the one we found in 1997, pit feature A2. So a lot of things concentrated in one spot. So looking from a side view, like we had X-ray vision looking through the site onto that surface, this is just the view without all those individual objects mapped. But what I want to show you are things called features. And features are sort of immovable three-dimensional objects or arrangements of things. So when we talk about like a pit feature, like the pit that we found in 97, it was located here and dug downward. There's a little bit of vertical exaggeration here, so it looks stretched. But this pit here began at the surface and penetrated through all these deposits and had these 4 spear points in it. This object, this is the base of a stem point, was actually behind the pit, not in the pit, but it's in another part of the site. And it's hard to kind of show everything compressed onto a wall. But we found this was our youngest pit. We found some next older pits here, and we found an older, even older depression, very broad at the top with a sort of a bowl-like depression in the middle. We found what we think is a fire hearth. It has concentration of charcoal. It has ashy sediments. It has orange burned ground associated with it. It has pieces of charcoal in it. On the right-hand side, these are all the radiocarbon dates that we have from area A in this layer 3. And I've, rather than show them in their exact position everywhere, I just simply show them by their elevation here. So I think it's an interesting way to look at it because from the top down, it's really nicely organized. It goes from roughly 13,115 to the oldest one at this depth down here, about a little bit past halfway down, is almost 16,000 potentially. Now, this is an age range. There's always an estimation of time here. It's not entirely precise. We can't say it happened on a Tuesday 13,000 years ago. You don't know that. We do have, 96% probability that the age of, for example, this pit feature is somewhere between 13,115 to 13,300. That's how we might think about it. But in shorthand, we might just refer to it as this is about 13,000 years. So essentially, layer 3 shows us that sediment accumulated over and over and over and over, and it built up, built up, built up. And as it was building up, windblown glacial dust was coming in. People were repeatedly coming to the site and leaving behind objects. Some of these were organic objects that we could get radiocarbon dates on. The things that are in bold text are charcoal, and the things that are not bold are pieces of bone. And I think what's also interesting is the sequence of charcoal and bone together, they actually are singing the same song. There aren't some major mixes up or reversals or things like this. So some of the criticism that has been levied against the work that we have done, the record we put forward at the site, is that the record in the archaeological site at the bottom of Cooper's Ferry is all mixed up, and you can't trust it. It's all somehow totally churned up, and it's not what they say it is. Well, I think that that's a fine hypothesis to put forward. It's perspective that should be considered, but the way to evaluate a hypothesis like is layer 3 and the archaeology in it mixed up is to simply look at the facts available. And one is we could look at the radiocarbon sequence. If it were horribly mixed up and rototilled, I would not expect to see it get older and older and older as you go downward. It would be that we might have a 16,000 at the surface and a 13,000 at the bottom. I would expect that if it was really mixed up. Plus, if this deposit was horribly mixed up, I would not expect to see things like hearths in place. This would be all blasted and spread around. I wouldn't expect to see really nice examples of things like pit features. So I have no reason to accept those kinds of arguments because the evidence suggests otherwise. Another thing that we found that was really interesting here, as I mentioned before, we found the flakes of production of stone tools. We find stone tool fragments that get left behind. We also find pieces of bone, and sometimes just they can be more visually identifiable. So here in this feature over here, this dish-like feature, we found an unusual piece of skeletal material that was this. It turned out to be a molar from a horse, an extinct horse, in fact. In fact, when we go back and look at its position, this is about in the time scale of somewhere between roughly 14 to 15,000 years. There's no direct dates over here. There are larger pieces of bone that come out of here, but they were really degraded. We tried to get some ages on them and it didn't quite work. And in fact, the bone chunks are so large that it makes me think that it could also be part of this animal. Now, we can't say that for 100%, but I think that's a pretty fair guess. So what does this mean? It probably means that people in part of their living in the canyon successfully hunted a horse and brought it back to the site and butchered it and probably ate it. So these are some of the tools that we found in area A and layer 3. We found the base of what we say might be a projectile point. This is the stem portion that would attach to the stick. This is another piece of a stem that was broken off. This is a piece of a blade, more business end of a projectile weapon. And these are flake tools that have just been modified to get cutting and scraping edges on them. And this is a blade. This is another blade. But the edges show little microfractures and polish, suggesting that they were actually used as tools. So by the end of our time working there, we ended excavations in 2018. We had amassed a whole bunch of data and working with a lot of different collaborators, you can see in this list here, we were able to put together a paper and present evidence that was reviewed and accepted ultimately to be published in the magazine Science magazine. So in 2019, we wrote this paper, Late Upper Paleolithic occupation at Cooper's Ferry, Idaho, USA, about 16,000 years ago. And this is during a time, 2019, when we were starting to see some other claims. It was around the same time as other kinds of sites were being talked about. The Galt site in Texas, Friedkin site in Texas, Paisley Caves in Oregon. So other kind of earlier sites, Page Ladson, for example, in Florida. Where there was new evidence coming out in sort of this first 20 years of the 21st century. And so this was adding to the stack of things coming in. Now, of course, not everybody, agreed with everything we were saying, and there were some questions that were posed to us, and so here are some of the critiques. And so some people had questions like, are the older dates from this layer 3 really associated with human occupation? Because some of them, for example, the deposits that were closer to 16,000 years old didn't have any features. There were no pits, there were no hearths. So how do we know those artifacts that are just distributed in the loess really go with these early ages? And also, where are all the projectile points? Like, why don't you have loads and loads of other projectile points there? You just have a couple broken bits of things that are older. Well, the good news is as we were excavating in area A, we were also excavating in area B. And the amount of information we learned from working in area A that went into that paper in 2019 took a lot of time and energy, so we could only do one part at a time. But I knew that we had other things that we could talk about the site still. And so let's look at this. We, as a result of also doing more work, 3 years later, we wrote another paper that talks about the evidence that we found in area B. And this is the title of it. We found basically a large tool assemblage at the site that dates to almost 16,000 years, and it extends the age of our understanding of stemmed projectile point technology in the Americas, and also was allowed us to sort of assess, is the record we saw in Area A, is it truly what we thought it was? And let's review the evidence. So here is just a view of some of the last days of excavating in Area A. And on the left-hand side is just what we call a composite stratigraphy. It's not meant to be exactly to scale, but it just basically shows you the sequence of things and the radiocarbon dates that go with it. So we have a whole bunch of stacked radiocarbon ages and features that in layer 3 down here in the bottom, we've already talked about this, between 13,000 and 16,000 roughly. In area B, we have a slightly different sequence over here. The elevation is just a little bit lower in this side of the site, and we have a little bit more stratigraphic variability. And this is because it appears that in the past, there was a stream channel that was sort of cutting through this part of the site, and the area A spot was a little higher and drier. So as a result, we have some erosional boundaries. So these red dashed lines show that there's some erosion is present, and we can infer that from the nature of the boundary, but also the abrupt shift in the timing between layer 4 here and layer 3. So this is roughly 11,000 years, and then immediately we jump to deposits that are about 15,000 years. So we know there's thousands of years of time missing, likely because of erosion. So some of the evidence that we found in here basically comes from features. So it isn't that we make the case that people are also in Area B, part of the Cooper's Ferry, Nipéhe, it's close to 16,000, just because of distributed items that are in the sediments. We actually found three-dimensional pit features, just like we had found before, in this side. And here is a plan view photograph looking down, or plan view drawing looking down, and you can see how densely concentrated the objects are. And I drew the line around them that corresponds to the line that we could map on the ground. And you can see here in the photograph on the right, this is feature 78. Feature 78 is a pretty clear boundary. You can look at it in the unaltered photo, and it creates this sort of three-dimensional shape. And as we excavated through this, we were very careful to try to map every single object we could find. Outside of the pits, there isn't a lot going on. So there's some items out here. These squares are pieces of bone. Um, and we actually found a projectile point out here too. But between these three pits, we found not only a lot of archaeological material, but we have found things that we could get radiocarbon dates on. This is a side view. Again, now looking through the wall, if you could see all the three pits stacked together, this is what they would look like. And so we have feature 78, 151, feature 108. So these pits extend down and they have these triangles are projectile points. So in these pits, we actually found caches of weapons that people had put in the ground and buried. And in addition, we found pieces of bone. We found production flakes from making stone tools and other items. And the radiocarbon dates that we get out of these were very similar to each other, suggesting that the pits were all made at about the same time, if not simultaneously. So we see, for example, feature 108 here on the right had a date that is between 15.8 and 15.6, 15,600. Again, 15,600, 15,800, 15,600, 15,000, almost 800, and so on and so on and so on. So they all kind of sing the same song between them all. These are the objects in terms of projectile points that were found inside these pits. So pit feature 108 had the most. They're all concentrated. The orange triangles are these projectile points here. Note this one right here. This one was found in place in this pit feature, and it fits on your thumbnail. So I like to jokingly tease my archaeological colleagues that Cooper's Ferry has evidence of the bow and arrow was invented at the Cooper's Ferry site, perhaps, but I don't know that we can say that on the basis of one small projectile point. But it is important to note that this had the edges of the haft part that you tie on to a stick, for example, have been ground down so they're dull with another rock, and it has been resharpened at least once. And it was resharpened, we think, in a haft, all wrapped up and bound, because you can see a portion of the blade that was not resharpened, called the ear. These had been worked to be resharpened, but they also have seen service. This one has an impact fracture. This one also has impact fractures in the base and the tip. So these are points that were used probably effectively to hunt animals, and they were put into pit feature and buried. These are other projectile points that were found in these other pits. In feature 78, I should say, these four came from there. And then outside the pit feature, we found this projectile point in an elevation higher than these, so we think it's younger. We found this one in a position lower outside the pit. So it is some amount of time older than roughly 15,900, but we don't know how much. So we, in previous years, had found another pit feature called pit feature P1. And this one was found in this lower Loess deposit, in the same kind of deposit where these other pits had been found that I just showed you. The problem here is that the archaeologists who work here in the 60s, B. Robert Butler, these are the deposits left behind from his work, and they're all swirly, twirly, dirt as we call it. And it's all mixed up. And it's basically from them digging down, and then they threw the dirt back in, and it got kind of mixed up. But they cut a trench through this area. We know this from the work that we've been able to put back together. And unfortunately, they chopped the top of this pit feature off. And then as we excavated, we found a circle again of different colored sediment in the loess. We dug down and found all of these projectile points together in a pile. And this was the last one here, this larger one. So unfortunately, there was nothing else in here. There wasn't lots of bone and debitage or charcoal or things that we could get a radiocarbon date on, but we know that it's likely being created about the same time as these other pits, because it had a lot of calcium carbonate was coating these objects. If we go back, you can see the white calcium carbonate. This was just on the edge, but if you were to flip these objects over, the back sides of them often are absolutely coated. And that means that they were present in the ground in a time before this soil developed. And we have dated this soil a bunch of times up and down the canyon now, and we know that it dates roughly between this time period. I can't, unfortunately, get more precise than that right now, but I think that that's pretty good. Okay, so in the end, we can correlate between area A and area B. And like I said, it's a little lower over here. The top has been chopped off a little because of erosion. But in the end, both sides are kind of singing the same song. They're just doing it a little bit differently, which is also why in archaeology we have to invest a lot of time in our training, not only ourselves, but also students, to be able to get good at understanding the geology of archaeological sites. This is a subfield known as geoarchaeology. And without having knowledge of how to figure this kind of stuff out, it would have been very difficult to be able to understand the story at the Cooper's Ferry Nipéhe site. So I'm pleased to be able to see, that how well correlated these two sides are. Now let's get back to these critiques that we had so we can address these questions. One was, are the older dates from layer 3 that we saw in area A, are they really associated with human occupation? We have features up here, like where are the older features perhaps? We have features up here, but you say there's artifacts down here, but how do I know they really just didn't get mixed or something in here? Well, the answer to that, I would say, comes from area B. And we can find stratigraphically lower pit features that were overprinted by this soil development that we also see in area A, and they have consistently older radiocarbon dates. I could also add to this, how do you know this site wasn't just rototilled and it's just a big mess and I just don't believe it? Well, I don't know how you're going to get pit features in a deposit moved vertically. That isn't happening. Rodents or tree throws or whatever your process is you're trying to infer, they're not going to move intact pit features like this. When they're in the ground, they look the way they do. That's the way that they were created. And you have just now found something intact. So we can also ask the question, well, where's all the projectile points? In area A, we only had some projectile points from the upper part. I don't know if I believe it. I want to see the points. That's a bias that archaeologists often have. And so we can address this. So here's the answer. The older projectile points are present. And we can look at them from area B, the lower part in the loess. We have 3 pit features with different projectile points. And they date to roughly this time range. As I said before, we have this other pit feature P1, that we can't date very precisely, but I think it dates inside this window somewhere, so we can order it, at least in a relative sense, this way. We have radiocarbon dates in spatial association with these objects that suggest they're probably being discarded at the site about this time. And then pit feature A2 contained these objects that with 2 radiocarbon dates that span this time period. So it's a pretty nicely stacked. They also occur vertically in the same sequence. These oldest ones occur deepest in layer 3, and these occur in the most shallow part of layer 3. So let's get to a conclusion. So archaeological research demonstrates that the site holds a layered or stratified record that's well dated by a lot of radiocarbon dates in good vertical sequence that span a period from about 16,000 years to roughly 8,800. We didn't get to the younger side, but that's about what it goes to. Ancestral Nez Perce people lived at the Cooper's Ferry Nipéhe site since at least 16,000 years ago. Now, there could be older occupation in parts of the site we haven't been able to date, so I don't rule out that there could be older occupation. And also, just because we haven't found even older ages at Cooper's Ferry doesn't mean that they don't exist in the canyon. It could be that we just can't measure it older because we don't have the deposits at the site that allow us to see that. But what we do know is that ancestral peoples returned again and again to leave behind cultural materials and features that give us a very unique perspective on their lives in the canyon. And despite criticism to the contrary, the evidence for a pre-Clovis occupation at the site is, I think, very strong. And this is revealed by the careful excavation and recording that we did over many years, finding multiple intact cultural features in undisturbed stratigraphic context. And these contain a rich array of cultural, floral, faunal remains that are well dated to 16,000 to 13,000 Cal BP. And working in collaboration with the Nez Perce tribe, myself and David Sisson, we aim to learn more about the archaeological record of the Lower Salmon River Canyon that corresponds to this time before memory, time immemorial, and to also find opportunities to show how traditional and scientific perspectives can be combined to build complementary views about the past. That, I think, is where the real magic can happen. when sometimes archaeology catches up to traditional perspectives and they start to kind of tell the same story. So I want to thank my research partners at the Nez Perce Tribe. Nikhil Williamson Cloud has been a very important partner. I want to thank him. And also, as I mentioned, David Sisson at the Bureau of Land Management, and also Kirk Halford and other people who have helped through the years, the management staff at the Cottonwood Field Office. Thank you very much. And also, I want to thank the students, many, many students that through the years helped to excavate this really important site. And I'm really happy at the results that we've all been able to come up with together. So thank you very much.
Thank you, Dr. Davis. That was spectacular. We have a number of webinars throughout the year around these topics, and that was incredibly clear. Thank you. Really a wonderful presentation of both the kind of what is it that, what are the rules for evaluating these kinds of pre-Clovis sites, and then obviously the work that you've done to draw in the indigenous perspectives is really spectacular. Just a wonderful example of hopefully how archaeology will, the future direction of our discipline. So thank you.
Thank you.
Well, everyone, I'm going to jump into these questions. I'm going to do my best to kind of lump them into some categories, right? So that we can kind of get some of the big topics addressed that are getting kind of repeated. So the dating, obviously the big question. Could you just talk to us a little bit more about the C14 results, the materials that they were derived from? We have some specific questions around that, like were you able to ID if they're plant materials? Were you able to get any IDs around that? So maybe you could just talk to us a bit about that, since that's obviously where the rubber meets the road, so to speak.
Right. Yeah. So in terms of the materials that we date two classes of materials, and one is charcoal, as I mentioned. So we have burned wood, and wood doesn't preserve typically at the site unless it's been carbonized. So, um, and almost always the charcoal is so small, it's very difficult for us to do accurate identifications of what type it is. Now, if we were just wanted to take an educated guess to which materials these are, I would say we're probably looking at trees that are accumulating at the edge of the river as driftwood, because I'm told that this is an important aspect of why people choose to live at a place like this. As I mentioned, it's sort of bring your own tree in the Salmon River Canyon. And I can also imagine that people are not walking to the top of the canyon to cut down a tree for firewood. They probably want to situate themselves close to where wood accumulates. So what I think this means is that we could have wood that's coming in that I don't really think the wood is in transit for a very long time. But if we have an old growth tree, for example, you could have a piece of wood that could be 100 years or more older than the time of its death. So the center of the tree could be older than the outside of the tree. Now, I don't really think that that's a big problem necessarily for the chronology of our site, because we also can cross-check these against things like bone. And so animal bone is the other approach that we use. And the animal bone fragments that we typically will get dates on are also very small. And we can't necessarily identify them through the means that we were using, let's say in the from 2009 to 2018. We didn't really have a lot of options for identifying them from very small samples. So what we can do is we're actually working with laboratories where we can use organic chemistry approaches that can identify the bone from very small pieces. So I just want to say we haven't identified the species when we date them, but we didn't really have a way to do that. So in terms of the specifics of it, we worked with Oxford's radiocarbon lab, and they do some of the best radiocarbon dating in the world. They pioneered a lot of the techniques that we all use as scientists. And I mean, there are lots of leaders, but they're some of the good ones. And we were very happy to work with them. The bone chemistry can be complicated, and we felt like it was in good hands with them. So.
Fantastic. Thank you. I love the bring your own tree. I might have to use that for tours at Chaco Canyon.
Yeah, no kidding.
Similar. It's a great phrase. It also kind of ties into one of the questions from our viewers around was the climate different 16,000 years ago? Might it have been more forested or wet? Could there be some changes that would need to be taken into account?
So if we look at the geology of the canyon from that time period, and we can move beyond the site itself to answer that, we've actually the Salmon River Canyon is a great stratigraphic record, even beyond archaeology. There are geological profiles we can look at that show us the dirt of this age, the dirt of the right age here. Mm-hmm. And we've extracted things like phytoliths, which are these little glass bodies that grow inside the cells of plants, and they're very distinctive for the type of plant. And what we know is that before about 12,000 years ago, there are a lot more trees at lower elevation. And so we think that the forest line after 12,000 years starts to really march up in elevation. The trees just cannot handle warming post-glacial environments so much. And so before, Euro-Americans came into this region, and it was probably very much like a bunch grass landscape. We do sometimes find evidence in the Pleistocene sediments of sagebrush is also present, perhaps. So it was probably a sort of a brush grassland, a lot of it. And but it was probably also very seasonally extreme. So we know the soil shows a lot of evaporation, that white crusty stuff that's on the artifacts. That's really common in desert regions. So, and this is the thing about the interior of the Northwest. It's like you're in two different worlds in different seasons. So, the winter can be cool and wet and very, very snowy, and the summers can be extremely hot and dry. And so as a result, the geology can sometimes show this, that we have extreme seasonality. And I think in the Pleistocene, we're probably looking at much colder and drier in the winters and probably drier in the summers too. So windblown dust would suggest that. You have to have really dry environments to have a lot of windblown dust.
Fantastic. No, that's a great explanation. Let's talk about the lithics. There's kind of a grouping of a couple different types of questions. So I'm just going to sort of throw them all at you and let you talk about it. Sourcing is one question, right? Of course, any refitting, right, that maybe had been attempted. And one of the sort of folks on the other side of the Clovis, pre-Clovis debate, we've seen a couple times, Todd Survell, who I'm sure you have run across in the sort of critiques of this, had an interesting sort of geomorphology talk that he gave to us a while back, where he was telling us everything we learned about stratigraphy when we were learning to be archaeologists doesn't really hold true, and talked about lithics moving around, right, in ways up and down a stratigraphic sequence in ways that we hadn't really thought about before. So with all that kind of sourcing, refitting, is there a chance that there's movement through layers of some of these artifacts? If you wouldn't mind chatting about that for us for a bit.
No, not at all. I mean, I have heard these. I may actually have these conversations also with Dr. Survell about this kind of stuff. So and my answer to that is just simply that we do know that there is vertical movement of objects at the site. And you may have seen these in some of the photographs. There are sometimes these circular polka dot different color parts. And one thing we do have at the site is rodent burrowing. And so rodents will burrow through the site. And when we excavated there in 1997, we dug that in 2 meter by 2 meter pit in 6 weeks. And so we mostly shoveled and troweled very quickly to get through it. And as a result, if you look at the early record that we sort of report, there are a lot of reversals and ages from top to bottom of the deposit. And I attribute that to the fact that we didn't map the contents of every rodent burrow in 1997. Now, let me be very clear. That was a 2 meter by 2 meter pit in 97. So David Sisson and I had a lot of conversations, and we learned our lessons that if we're going to do this work moving forward, we have to have different strategies. And what we decided was we are going to do the ridiculously audacious thing of map every single rodent burrow and excavate every single rodent burrow separately. So this is why it takes 10 years to excavate out this big volume that we did, because we had to map a lot of things precisely. So we mapped several thousand rodent burrow sections. And when we would excavate material, we would keep them separately. So the contents of rodent burrows get mapped and excavated and screened separately than the stuff outside the burrows. Because, and so when I show you distributions of objects, I'm only showing you the things that are outside of rodent burrows, because I'm not interested to tell a story about how gophers are moving things. That's not what we're trying to do here.
Right,
So
right.
the other test for that kind of question of, are things being moved around vertically, as I mentioned before, is the radiocarbon chronology. So we can look at the position stratigraphically, or the position with depth at our site of what our ages are. And if arguments about mixing are correct, then we should expect to see that. We should expect to see a lot of scrambles. Things
Right.
don't make sense. Young stuff's at the bottom and old stuff's at the top. But that isn't what we see as a result of the careful methods that we've used. Now, I've read the paper, and that Dr. Suravel presented on when he was a guest here. And his argument is essentially, if we look at the distribution of items, that you should see these big peaks and then gaps and then peaks and gaps. Well, another way to look at that is you can ask the question of, what are people doing? So if people only occupy your site sometimes, and they have long periods of time where they don't occupy the site, if the windblown dust is continuing to accumulate, it's going to bury your occupation layer. Then you're going to have a part of the site that doesn't really have anything in it because people weren't there. And then when they come back, they make a big layer again.
Mhm.
Well, I would argue Cooper's Ferry was probably a very, very great place to live for a very long time. And so as people are constantly coming back, coming back, coming back, they just create an archaeological record that Servo and others have argued means mixing. But I prefer to simply do it on the basis of things like the position of radiocarbon dates, the position of
Mhm.
features, occupation services. So the actual physical things. I don't want to second guess myself with theory. I'm just going to look at the facts. So
Nice, nice. And are there sources, the source types nearby?
right.
Yeah.
Yeah, there are. So well, not all. So the three main tool materials we get are what we call chert, or cryptocrystalline silicate is the really nerdy way to say that. So you can think of an agate, like if you go to the beach and find an agate, or you in the desert and find an agate. It's that kind of glassy rock, and that stuff is really common in the Salmon River Canyon. It forms inside the basalt lava flows as a secondary sedimentary rock. There are loads of it in the canyon. All the material that we have seen, that we've measured so far, and master's thesis was done on this at Cooper's Ferry, and almost 1,000 items were sourced to essentially things that are within about 20 miles. Now we have lots of other items but I don't really have any reason to suspect that they're coming from long distances away, because you can find this material everywhere. So we also see that people use fine-grained volcanics like andesite and basalt. That can be popular too. And then we do have obsidian, but obsidian is very rare. It's like less than 1% of the total content. And it will come from areas, tens to 100 plus miles away. And so as a result, it's just not very early. I should say, I can mention this to your audience as long as everyone promises not to say anything. We have we have evidence at the very bottom of the site of obsidian and vitrifier. Vitrifier is another kind of obsidian-like rock, but it comes out of these very early deposits that are between 14 and 16,000 years or so. And these are probably the earliest evidence of people using obsidian volcanic glasses in the Americas that we know of. I've never seen an earlier version of this, but they come from places that are established ones that the Nez Perce will use all the way up to contact. So I think what's exciting about that is you can look at the archaeological record of a site and say the things that the Nez Perce already know very well are already established by time periods like 14, 15, 16,000 years. So, and they will continue these practices through time.
That's wonderful. Wait, our indigenous partners tell us all the time everything is a lot older and more complicated than any of you think it is, and they're often, as science catches up, often that
Right.
is the case. Let me throw it. There's some fun questions that I want to reward the people who put their questions in the Q&A early. So on your when you were talking about your first excavation, great question from one of the viewers says, how did you choose the exact location of that first excavation where you found the pit? Was there some kind of surface expression or was it just incredible luck?
Well, I didn't want to excavate in the same place that I thought the other archaeologists had dug. I didn't want to dig through their back dirt, as we call it. Um, and I had found a map that showed that there was an old historic road in the vicinity of where we dug. And I thought one of the rules of sort of living in places where you have to put a lot of sweat equity into making roads is don't dig a hole in the road. So I thought that place was probably has been protected for a long period of time. It wasn't messed up. In the end, we just had to choose something and we excavated down from there. And I have to say, I laid out the grid of my how we were going to put the square on the ground, and I had the declination wrong in my compass. And if I had done it correctly, adjusted it later, and I thought, man, if I had done this correctly, it would have rotated the square, and we would have missed that pit. So again, it's some of dumb luck a little bit, but honestly, there are lots of pit features at the site. So I have a feeling that we probably could have chosen other places to put it, and we very likely would have run into another one.
Yeah, fantastic. That's a great story. So obviously this is a hugely popular topic with our viewers among many, many other people, and our folks are kind of following, the notable press and discoveries. And so I was wondering, someone asked if you had thoughts on how this site maybe plays into the White Sands discoveries, or really anything. I think if you think about all of the other sites that are being called pre-Clovis, what do you think about that?
Yeah. Well, I mean, specifically talking about the White Sands one, there's a big conversation that's happening among professionals, at least, about the timing of the White Sands footprints. And I have been involved with some of the papers written about that. And we ask questions about what is it that's like getting back to the rules. What is it that's being dated? Does it tell you the timing in the way you think it does? But I don't have to get into that so much, but the point is that as we excavate other early sites, and for viewers that want to learn more about this, you can find information on the web about sites like Gault, Gault, the Gault site, and Friedkin is another site that's near the Gault site. You can learn about Paisley Caves. You can learn about Page Ladson. These are the kinds of sites that have an archaeological record in them that are showing us the actual way in which people put their thoughts into material expression. Now, what I mean by this is if you're going to ask questions about how are these Cooper's Ferry and the Baja, how is it related to the Galt site in Texas? Well, I mean, we can't talk to the people, of course, that were there, but we can look at the things that they were making. And the things they were making are the end product of them thinking about something. They had a design in mind and they had a mode of manufacture. And so the stone tools that you see at the very early part of the Galt site, for example, there are a lot of, and Friedkin site, there are a lot of similarities with the early stuff at Cooper's Ferry and the Paha. You have stemmed points and they're very small, are coming out of the stuff that's below the Clovis layers in these sites. So we're not so alone, I suppose, in making these comparisons. Now, North America is a big place. The Americas are a big place. And just because you have a couple dots on the map, it's pretty hard to connect the dots and make it all clear. And I think that's going to take a long time before we really know a lot of these things and how it all goes together. But there is definitely some shared cultural aspects in the ways in which people make stone tools. And just like in your region, you can look at the way people are making other material culture things like ceramics or houses or whatever. I mean, people are people all over the place. They can share these ideas. So then the question is, why is it that people make them like this in these distant places from each other? It can be a bit of a mystery, but it's exciting for sure.
Absolutely. I'm gonna pick on our staff, some of our lab staff who are watching and have popped in a question. So from folks at Crow Canyon, their comment and question is: your research has been central to a seismic shift in our understanding of the peopling of the Americas. Given the growing widespread acceptance for a pre-Clovis habitation of North America, what do you think is next for late Pleistocene archaeology in North America?
Well, I hope that, people get excited about, as students and professionals, get excited about the idea that we should find more of this kind of record. And we should also, maybe I should step back and say, we should begin by trying to find ways to explore more about the deep past in a way that matters to indigenous communities. That's a big challenge too. And I think that that's something that we should want to try to do together. And I've had conversations with cultural staff at the Nez Perce, and we are trying to find lots of new ways to work together. We've been writing grants, fingers crossed that we actually get research money in this country going forward. And the things that we are trying to do together, I think, are trying to make progress on those things, because we now are beginning to understand more, at least where I work, where the dirt of the right age exists and what it looks like. And so we can probably get pretty close to finding more evidence of early sites if they exist. But what I want to do next, I would like to do more of that work with the Nez Perce, with the tribe. That would be a lot more important for us to share these experiences, and also to help them become the experts on their own heritage in the archaeological sense of building technical capacity. They have professional staff that also works there. So that's part of what we want to do. But I think that you have to begin to think about this also too from a geology point of view. Until you can find the haystack, you can't find the needle. So if you don't know where 15,000-year-old dirt exists in layers in your region, you need to figure that out first. So you need to know where these are being held, because the same record, of course, doesn't exist in Colorado that it does in Idaho. You have totally different geologic history. So if I was to move to Colorado, I would just have to begin again. I would have to start from the basics of what do we know already? And based on what we know, where then could we look to try to find these layers? And then once you find the dirt of the right age in certain places, you have to ask, is this dirt of the right age in a spot that people would want to be? They want to hang out here and leave behind things for me to find thousands of years later. So those are also some of the challenges. But in terms of the work that I'm doing, what's next? There's a site on the same landform as Cooper's Ferry in Nipéhe that's about a mile downstream. And we've started to work there together in collaboration, of course, with the BLM, but with the Nez Perce tribe. And we've already found more stemmed point occupation in the same place that we expected. And it's not as old yet, but it's getting older and older as we go. And we're going to be back there again this summer, looking to learn more about it. And there's just a lot of things I want to do. There's so many things I haven't done yet, and I've got to get the Cooper's Ferry site written up. And there's many, many other stories to tell about the site that I didn't have time to discuss today that aren't just about the very early stuff. So I'm looking forward to that. Did I answer that question?
Perfect. That was perfect. And just really encouraging to all of us here who are working to kind of do exactly that, right? To really try to build the kind of collaborative research, what's interesting and important to our Indigenous partners and colleagues, and how can we work together to do this kind of research and education. So thank you for your wonderful work and fantastic presentation, and for being such a popular speaker in our series. And we sure hope to have you back. And if you do find yourself in Colorado, this is our campus behind me. We would love to host you.
Thank you very much. Thank you. And hey, everybody who's listening, if you were excited about all this, please support Crow Canyon. It's a great place to learn and to get things done. So,
oh, you are now my favorite webinar speaker ever. So thank you so much. And we hope to see you again soon.
Okay, thank you.
Okay, bye, everybody.